We like to think we have space figured out. We map the orbits, we calculate the exact physics, and we launch multi-billion-dollar machines expecting the universe to behave exactly how we want. But over the last few decades, the further we've pushed into the dark, the more we've collided with things that leave the smartest scientists on Earth completely stumped. These are 7 of the most disturbing events in space in recorded history. On October 15, 2003, Yang Liwei became the first Chinese astronaut in space, circling the Earth completely alone on a brief 21-hour mission. Somewhere in the middle of that flight, he heard a knock. He later described it as a wooden hammer tapping an iron bucket, with no rhythm or warning. But because sound can't travel through the vacuum of space, a knock from the outside is a physical impossibility. Whatever was making the noise had to be coming from the ship itself. Yet every time Yang floated to the porthole, he saw nothing but empty space. The sound didn't care whether he was flying over the day side or the night side of the planet, and it followed no pattern at all, sometimes going hours without a single tap before suddenly starting up again. Engineers spent months trying and failing to replicate the noise, and the mystery only grew when the next 2 Chinese crews reported hearing the exact same phantom tapping. Yang even sat down with technicians after the flight, trying to imitate the sound while they recreated it with instruments, but he later admitted that nothing they played back ever sounded quite right to him. Today, scientists believe shifting pressure between the sealed cabin and the vacuum outside was slowly warping the ship's inner walls, causing the metal to pop like a plastic water bottle on an airplane. Yang himself noted that this matches what he heard, though the phenomenon has never been officially confirmed. This kind of deep isolation has a strange way of messing with human senses, something NASA learned during the Apollo era. In May of 1969, 2 months before the moon landing, NASA sent Apollo 10 on a full dress rehearsal. Thomas Stafford, John Young, and Gene Cernan flew all the way to lunar orbit to do everything but touch down. Part of that mission took them around the far side of the moon, where 2,000 miles of solid rock blocked every radio signal from Earth. For those long minutes, the 3 men were completely cut off from the rest of the human race, so thoroughly isolated that if anything had gone wrong, there would be no way to even call for help. In that total isolation, a strange, continuous whistling started bleeding through their headsets. On the surviving audio tapes, the crew can be heard nervously describing it as outer space type music. It went on for nearly an hour. At one point, Cernan asks whether the others can hear that whistling sound too, and while they can, none of them can explain what's making it. Before they re-established contact with Houston, the 3 men actually debated whether to report it, worried that Mission Control would think they were losing their minds. The music turned out to be simple radio interference between the lunar and command modules. Michael Collins heard the exact same eerie tone on Apollo 11 a few months later, then admitting it would have terrified him if engineers hadn't warned him about it first. 8 years after Apollo 11, the focus shifted from the moon into deep space. In August 1977, Ohio's Big Ear radio telescope was quietly scanning the cosmos for signs of artificial life. Days later, volunteer astronomer Jerry Emmon was parsing through the data printouts at his kitchen table when he found something impossible. A transmission was blazing across the page, 30 times louder than the static of deep space. Holding steady for the full 72 seconds, the telescope could watch that patch of sky. Even the shape of the signal was unnerving, because its strength rose and fell in the exact curve you'd expect from a fixed point in deep space drifting through the telescope's view as the Earth rotated, which essentially ruled out any interference coming from the ground. It clocked in at 1,420 megahertz, the precise universal frequency of hydrogen, which scientists always assumed aliens would use to broadcast their existence. Emmon was amazed, so he circled the code in red pen and wrote "wow" next to it. Astronomers have aimed far more advanced telescopes at those exact coordinates over 100 times since, but the sky has remained completely silent. A 2017 hypothesis tried to blame the incident due to a passing comet, but it was rapidly dismissed because the positioning was off and comets cannot produce such a sharp, intense beam. And a recent reanalysis of the original data found that the signal was actually about 4 times more powerful than anyone had estimated, with the best natural explanation now requiring a rare stellar flare striking a cold cloud of interstellar hydrogen at exactly the right moment, an event that has never been recorded before or since. Nearly 50 years later, it remains the strongest candidate alien signal ever received. The telescope that heard it never got a second chance either, because Big Ear was torn down in 1998, and today a golf course sits on the exact spot where the message came in. 40 years after the WOW signal, telescopes picked up something even more unprecedented. In October 2017, a Hawaiian telescope captured a faint dot moving at speeds that defied the sun's gravity. It was Oumuamua, the first confirmed object from another star system ever detected. By the time astronomers caught it, the visitor had already rounded the sun and was screaming out of the solar system, giving the world's telescopes only a few brief weeks to observe it. And when they traced its path backwards, they realized it had already flown right past us, coming within 24 million kilometers of Earth a full 5 days before a single person noticed it was there. Almost nothing about it made sense. Its brightness spiked and plunged as it rotated, implying an extreme elongated shape like a 400-meter cylinder or a flat disk. It wasn't even spinning cleanly. It was tumbling chaotically end over end, the kind of motion you'd expect from something that survived a violent collision back in whatever system it came from. The strangest of all, it had no comet-like tail of debris, yet it was mysteriously accelerating away from the sun. While comets gain thrust when solar heat vaporizes their ice, Oumuamua remained entirely clean. The data was unusual enough that Avi Loeb, then head of Harvard's astronomy department, published a paper arguing it was consistent with an artificial solar sail. Most scientists rejected the alien hypothesis, arguing instead that invisible escaping hydrogen was providing the thrust. With the object gone forever, the debate is essentially stuck there. But the two interstellar visitors described since have both behaved like ordinary comets, which only makes Oumuamua look stranger. Yet the deeper we look into the cosmos, the more the very structure of the universe seems to break down. In 1981, astronomer Robert Kirshner and his team were building a three-dimensional map of the universe by measuring the distances to thousands of galaxies. When they looked toward the constellation Boötes, they found a massive hole in the map. It was a roughly spherical region 330 million light years across, and it was almost completely empty. To put that into perspective, a beam of light entering one side of it would need 330 million years to come out the other. A space that large should contain roughly 2,000 galaxies, but after decades of searching with better telescopes, astronomers have only found about 60. They ruled out dust, telescope errors, and missing data. The region simply earned the nickname the Great Nothing. The scale of the void is genuinely hard to comprehend. The astronomer Greg Aldering pointed out that if our Milky Way sat in its center, humans wouldn't have even known other galaxies existed until the 1960s. Everything else would have been too far away for early telescopes to see. So any civilization living in there would reasonably conclude they were completely alone. They could build perfect telescopes, point them in every direction, and find nothing but blackness staring back for hundreds of millions of light years. The standard explanation is that the universe is built like a foam, with galaxies gathered around walls and empty bubbles in between. Those bubbles grow naturally as gravity drains matter out of them and into the walls. But a bubble this enormous is far bigger than that process normally produces, which is why most astronomers believe it didn't grow alone. Boötes likely formed when several smaller bubbles merged into one. We actually see evidence of this, since most of its 60 galaxies line up in a rough tube through the middle, likely the leftover wall between two former voids. Even so, it sits at the absolute edge of what our models can comfortably explain. In July 2012, we got a stark reminder of just how dangerous our own solar system can be, when an apocalyptic solar storm crossed Earth's orbit and missed the entire planet by just 9 days. The sun had fired two massive eruptions that merged into a single billion-ton wall of plasma. A preceding flare had already cleared the path, allowing the storm to cross the solar system in under 21 hours instead of the usual 3 days. It ripped through space at 2,000 kilometers per second, annihilating simulating the exact spot Earth had been sitting in just over a week prior. If it had hit us, the grid would have collapsed. The assault would have arrived in waves. First, a flash of radiation hitting at the speed of light and knocking out radio across the sunlit side of the planet. Then, a swarm of charged particles frying satellite electronics minutes later, and finally, the plasma itself slamming into Earth's magnetic field about a day after that. Data from a surviving solar observatory showed the blast matched the 1859 Carrington event, which famously set telegraph lines on fire. For a smaller preview of what that means today, a storm a fraction of the size hit in March of 1989 and collapsed the entire power grid of Quebec in roughly 90 seconds, leaving 6 million people in the dark. The 2012 cloud was about twice as strong. A strike of that magnitude in the modern era would physically burn out the massive transformers that run global power grids, hardware that takes years to manufacture. Satellites, GPS, and aviation would go dark, causing an estimated $2 trillion in damage and requiring up to 10 years of recovery. The scariest part was that nobody outside a small circle of researchers knew it happened, and the terrifying near miss wasn't made public for almost 2 years. According to the same scientists, we have a 12% chance of getting hit by a storm that size every decade. But the sun isn't the only thing capable of destroying our orbital infrastructure. We are actively building a trap of our own right now. In 1978, NASA scientist Donald Kessler pointed out a major flaw in how we use space. He calculated that once we put enough satellites into orbit, a single crash would trigger a permanent chain reaction. If two satellites collide, they shatter into thousands of pieces. Those shards then scatter, whipping around the globe to smash into other satellites, creating even more debris. It's a runaway effect that could eventually trap the planet inside a cloud of high-speed wreckage, making spaceflight impossible for generations. Because objects up there move at 28,000 kilometers per hour, even a stray bolt could carry enough kinetic energy to instantly destroy a spacecraft. For decades, this was just a theory. But then, in 2007, China blasted one of its own dead weather satellites with a missile, shattering it into more than 3,500 trackable shards and instantly increasing the amount of space junk by 25%. Then, in 2009, the first major accidental collision occurred. A live American communication satellite and a dead Russian military satellite slammed into each other over Siberia at 42,000 kilometers per hour, creating another 2,300 pieces of wreckage. And those are just the chunks big enough to follow with radar, because underneath them sits an invisible swarm of well over 100 million smaller fragments, each one moving fast enough to do serious damage to whatever it hits. One of them, likely a stray fleck of paint, has already gouged a chip into one of the space station's windows. Today, the International Space Station regularly has to fire its thrusters just to dodge these fragments, forcing astronauts to shelter in their return capsules during close passes. Kessler always maintained that this wouldn't be a sudden overnight disaster, but a quiet accumulation over decades. And the math is only getting worse, because more satellites have been launched in the last 5 years than in the previous 6 decades of spaceflight combined, packing the busiest orbits tighter every single month. In fact, he argues that in our most crowded orbits, the chain reaction has already begun. If you enjoyed this video, make sure to join the Discord server below. You get to watch new videos early, suggest your own video ideas, and chat with others. Thanks for watching, and I'll catch you next time.